Hey, welcome to your video practice test. I hope you've done some revision for this. Anyway, do you know how it works? I'm going to show you question by question, and I want you to pause the presentation after you see each question, and on your own work, on your own paper, write down your answer, and then let the video run forward and go through all the questions. I think there are 7 questions for 36 marks. And then I want you to stop, check your work, then roll the video and go back and watch me go through the answers and work the problems out, and go over it so you get the idea. Just don't be happy with your mark. Find out what went wrong if you got any incorrect answers. So let's go now. So here we go. This is Pythagoras' rule here, and there's question 1. So I want you to pause the presentation, have a go, and then we'll come down and have a look at the next question. Here we go. Question 2, worth 6 marks there. So copy the triangles down, try to work them out. Pause it there. Right, we're going to move on. Question 3, worth 6 marks, 2 each basically. And question 4. This one I think is worth 3 marks, yes. Give the answer to 1 decimal place. And question 5. This one is 4 marks. Give your answer to 2 decimal places. And question 6. There's 2 parts to question 6. Part A, worth 8 marks, so do a bit of work on that one. Think carefully. And then part B, what would it cost to replace all the cables if the price was given? Okay, and the last question is question 7. To draw a little bit of a diagram here, and then answer a bit of a Pythagoras question on it. Okay. So if you've finished that now, I want you to pause the presentation, and because I'm going to go through it now, and you can mark your work. Too late to change anything now. Let's go back and let's have a look at the answers now. So here we are, Pythagoras practice test, and you've got to put your name on it. So here we go, better put my name on it up here. How do you see how many marks I can get, mate? And the total mark is out of 36. So let's try now. So state Pythagoras' rule for the following triangle. The square on the hypotenuse equals the sum of the squares on the other 2 sides. And we generally write Pythagoras in brackets there. So did you get that one? That's only 1 mark. And they all have to be correct in the right order there. You could have q squared plus r squared, but you must have p squared equals. Okay, let's have a look at question 2 now. Find the missing side in the following triangles. So let's call that missing side x. So square on the hypotenuse equals the sum of the squares on the other 2 sides, and the mathematical reason in brackets, and that implies x squared is 9 plus 16, which implies x squared is 25, which implies x is plus or minus 5, but x equals 5 because x is greater than 0. It's a length of a side, so x is greater than 0. There's 2 marks for that. Only 1 mark for stating Pythagoras and 1 for the answer, but you'll be penalised if you don't put in reasons there. Pythagoras and x greater than 0. But just remembering, neg 5 by neg 5 here will give positive 25. There are 2 possible answers to the equation x squared equals 25. Okay, let's do the next one. X is there, so x squared equals square on the hypotenuse is the sum of the squares on the other 2 sides. Pythagoras, that implies x squared is 49 plus 25, which implies x squared is 74. And that means you can just put x is the positive root of 74 because x is greater than 0. and that implies, now you've got to use a decimal here, so x is approximately 8.60, three significant figures. Okay, so 2 for that as well. Remember, we should put in these reasonings why you've only got one answer there. And I didn't tell you to actually simplify this radical, so either of those two answers are okay. So one for putting down the correct Pythagoras, and one for getting correct Pythagoras statement, and one for getting the correct answer. X here on that side, x squared, square on the hypotenuse, sum of the squares on the other two sides, and that's by Pythagoras. So that implies x squared is 144 plus 25, which is 169, and therefore x is plus or minus 13. We'll just choose 13 because x has to be greater than 0 as it's the side of a triangle. Can't have a negative side. So again, 1 there and 1 for the answer. So pretty easy marks here for a start. Let's warm up a bit and go to question 3. Here, find the missing side of the following triangles. If the answers are not whole numbers, give the answer to one decimal place. Okay, where's the missing side? Over here. So this time, the square on the hypotenuse is 10 equals the sum of the squares on the other two sides. Again, by Pythagoras. That implies 100 equals x squared plus 64. Now, x has been squared and 64 has been added. You see that here. Let's take away 64 from 100. So x squared, before the 64 was added, must have been 36. So that means x was 6, because x must be greater than 0. I should put in there centimetres. Okay, so this is again worth 6 marks. So it's 1 for the first statement and 1 for the answer. You must have some reasons in here or you will be penalised. Okay, so let's do the next one. X is down here now, the missing side. So the square on the hypotenuse is the sum of the squares on the other two sides, and that's again Pythagoras. So that implies 36 equals x squared plus 4. Subtracting 4 from both sides, before you added it, x squared would have been the number 32. Okay, so that means x is the square root of 32, and that is x is approximately 5.7, 1 decimal place. And this is because x must be a positive. Okay, again, 1 for the correct statement, 1 for the answer. Down there at 5.7. Remember, going back up the top, 1 decimal place. Let's have a look at the last one. X is over here. So the square on the hypotenuse, there's the hypotenuse opposite the 90, is equal to the sum of the squares on the other two sides. I'll just square the 6 to get 36. So 81, that implies, tell the story, that implied sign is like punctuation in English. It's telling the story. And then let's go down now. This implies 81 take 36 is, what is that, 45 equals x squared. And that implies x is approximately 6.7 centimetre, what's this? This one's in metres. So we really should put the correct units there. So that's in metres. 1 decimal place, 1 dp, and putting that x is a positive. Because remember, when you square a number, it could be a negative times a negative if you were positive. So same mark scheme, 1 up here, you must have 9 squared equals. You can't have x squared equals. And 1 for the answer. I hope you're getting some marks here. Okay, let's go on. We're going to go into the more interesting applied ones now. So the gate is shown below, needs to have a support strut across it. as drawn, so it has greater strength. The builder needs to find its exact length. Using x as its length, there it is, there's the strut. Find the length of the strut to 1 decimal place. Let's use Pythagoras. There's the 90, so the square on the hypotenuse equals the sum of the squares on the other two sides by Pythagoras. Always putting down the maths. Well, really, for the triangle that we're working in is that top one, isn't it? So we should be up here looking out, and that's the hypotenuse. Same idea. So this leads to, or implies, x squared is 25 plus 9, which implies x squared is 34. We'll just come up a little bit now. And therefore, x is approximately, notice this approximately sign, because we're rounding it off, is 5.8 metres to 1 decimal place. Okay. Again, because x is greater than 0. That's worth 3 marks. You can probably see that. 1 for that, and it's a bit harder to get, and 1 for the approximate answer. And we need to have that in there as well. So I penalise you there. 1 decimal place. So there, if you've got all of that, you will have 3 marks there. All right, how are you going? I hope you're getting a few marks. Let's keep going now. Here we are. Oops, too far. The diagram below shows the foot of a ladder. So here's the ladder, the foot of the ladder, resting on the ground 1 metre from the base of the wall. If the ladder is 2 metres long, how high up the wall does it reach? Give your answer to 2 decimal places. Well, let's have a look. Let's call this the height up the wall. So the square on the hypotenuse is the sum of the squares on the other two sides. There's the 90. So hang on, let's scrub that out. I've messed that up on the screen here. So the hypotenuse is opposite there. And again, the mathematical reason is Pythag. So 4 equals 8 squared plus 1. So leading on, that implies take 1 from both sides to get back to what 8 squared was before we added 1. And so now h equals square root of 3, because h is greater than 0, you can't have the negative there. So that implies h is approximately 1.73 metres to 2 decimal place. Okay, because it says up the top here, look at the top, to 2 decimal places. All right, how are you going? Now that's 4 marks, so there's 1 for that, 1 for getting down to there, and 1 for that, and 1 for rounding the answer off to 2 decimal places. Okay. Getting a bit more interesting, isn't it, doing these practical problems? So come down, question 6 is an interesting one. Question 6, you need to think of it in a couple of different ways. So let's rewrite the triangles here. We've got this long strut or wire. That's that one I'm talking about here. That's 12 metres. There's your 90. Oops, that's not 12 metres, that's the length we want. Call that x. And 12 metres is the actual height of the flagpole. And let's have a look along here. That's actually 5 metres long for that big wire along the base there. So we're going to draw that diagram. What about the little strut, the little wire, keeping it straight? A bit hard to write on the screen here. We'll just come across here. See what I'm doing? Extracting the right angle triangles, and this one here is 6 metres. And let's call that y for the shorter wires. There's 2 wires there, aren't there, being used to support that flagpole. And later we're going to have to look at these. They've done it 3 times around a sort of triangle to get support for that flagpole. All right, let's do it here now. The square on the hypotenuse is the sum of the squares on the other 2 sides. So that's by Pythagoras. That implies x squared is 25 plus 144. I think you might recognise that as a Pythagorean triple. X squared is 169. So that means x is 13 metres because x is a positive. So there we have that one. Now let's look at the shorter length. So the square on the hypotenuse is the sum of the squares on the other two sides. Always putting in a good mathematical argument, which implies y squared is equal to 4 plus 36 is 40. So y is the square root of 40. It's got to be the positive root because y is greater than 0. So that implies y is approximately, now what are we going to do here? 6.32 metres, and that's to the nearest centimetre. It doesn't tell us how accurately we should state these. But there we go. Now we haven't finished the question. This is a biggie because we want what length of cabling would be needed. So that goes right around the pole. Let's go back. See here, we've got a section there, as well as this section. So there's 3 lots of both of them. So the total length, I've run out of room there, will be 3 lots of the bigs, the long ones, plus 3 lots of the shorter ones. So what that comes to is approximately 39 plus 19, taking it to the nearest metre, 3 times this one. Okay, so it's approximately 58 metres in total. And there's 8 marks for that. Let's see if we can get them. So there's 1 for that, and 1 for the answer, 1 for this, and 1 for the answer. And I'm only getting 6 here, so I'm going to give you a bonus one for going in there and there. And then 2 here for realising there's 3 lots of each and getting 58 metres. So I've been a bit too generous with the marks there, I think. Okay, so give yourself 8 if you could get all that right. What would it cost to replace all the cables if the price of the cable was $15 for the larger metre for the longer ones and $10 for the smaller ones? Let's look at the longer ones. So the long, we've got 39 metres times $15, and if you work that out, that's $585. And then the shorter one is 19 metres times, the price there is $10 a metre, so that's 190 metres, $190, sorry. Okay, so that's 585 and 190, the total cost is $775. So there's the long and the short there, and then there's the total. The total is that. Slipping on the screen there. Okay, so there's 2 marks, 1 for that and 1 for that. Okay, I hope you're getting some marks there now. Let's have a look at the last question. A little diagram needed here, practical one. A person starts here and walks north, up that way, 11 kilometres. Then turns east and walks a shorter distance, 6 kilometres. Draw a diagram. Okay, so that's a diagram. There's the person, and that's where they finish. Okay, a little diagram. So you could join, you must have the 90 and label these 2 distances to get the 3 marks. So make sure you put a tick for each of those points. How far is the person from his or her starting point? Well, let's look at what we've got now. We've got 11 and 6 and a 90, because there's 90 between north and east, isn't there? All the points of the compass. Okay, 90 degrees between each of them. So the distance, d squared, it's the value on the hypotenuse. The square on the hypotenuse is the sum of the squares on the other 2 sides. And the reason is That's what Pythagoras said. So that implies d squared is 36 plus 121, the 157. This is all in kilometres. Oh, and kilometres squared to be there, so we'll just leave that out and take the square root of it. So d is the square root of 157, because d must be greater than 0. And the square root of 157 is approximately 12.5299 kilometres. And it keeps going, the decimal keeps going, I think, there. So give your answer to the nearest metre. If this is kilometres, this is equal to 12 point, or put approximately again, 12.530 kilometres, because this is a thousandth of a kilometre, which is your nearest metre. So it's 12 kilometres and 530 metres, if you like. Just remembering, if the units are kilometres, that third decimal place is a thousandth of a kilometre, which is 1 metre. So that's where we have to end up. Have a check of that one. Okay, 3 marks there. 1 and 2 down here, and 3 for the correct metre. 12.530 kilometres is okay. That it didn't say give it in metres, it says to the nearest metre. So you had to recognise that that decimal place was the level of accuracy you needed. All right, well, I hope you've done well there. I hope you got some marks because it's a good preparation for the test. Now, I hope you can do a bit more study before the actual test so you can do even better. For me now, it's cheers.